Okay, just a little background on planes here. Think of a plane as like a big sheet of paper, but it extends indefinitely. In other words, it goes forever. And it's like an infinite sheet that keeps going on. I think people want to make it like a flat sheet of paper, and then they just think that it ends, but it doesn't. It has, again, zero thickness because it's made up of points, which also have no shape. They're not round circles like we make them out to be. They are infinitely small. To name a plane, you just need three what we call coplanar points. In other words, they're all in that plane. So let's say A, B, and C are all in this plane. I'll explain coplanar here a little bit better in a moment, but if they're all in that plane, we can name it with 3 points. We could also just name it with one capital italicized letter. In this case, we called it R, but it could be anything. I mentioned here that how many planes can go through three non-collinear. In other words, this is collinear if they're all in a straight line. That's a horrible line, by the way. Let's make that better. So 1, 2, and 3. If they're all in a straight line, that's something different because actually infinitely many planes can go through there. But if they're non-collinear, only one. If we keep looking at these, when of course lines intersect, if they do intersect, of course they might not if they're parallel, but if they do intersect, they always intersect at one point. If two planes intersect, they always intersect at a line. I'll show you this in a moment. And of course, if a line and a plane intersect, the only time they wouldn't is if they were parallel or if the line was actually in the plane. But if they're if it's intersecting here, it's always going to intersect at one point. So just kind of take note of those things. And last but not least, coplanar means any points that are in the same line. Like if I draw points here, okay, these points right here that I'm drawing are all in the exact same plane as my laptop screen. That's why I can see them all. My laptop is only two-dimensional like a plane, and that's why they're all on there. So these would all be coplanar. Let me show you this example here now with a little applet here that we have. So if I go back, actually I'm going to go back to this picture here. This picture here, what I have here, I'm just going to move this around, rotate this. You can see what I have here are two planes, one green and one red, kind of illustrated here. And I just want to point out, and of course you see some other axes, a couple things here. Actually, where the line, let's say this blue line here, cuts through the plane, notice, and I'll just kind of rotate here, notice it goes through one spot. Okay, through both these planes it's going through a spot, and that's of course one point. And that's what we meant before by like when a line intersects right there, maybe it's a good picture, when a line intersects here, it intersects a plane always at a point. Other thing to note here is that when these two planes intersect, is red and green, they're different planes here. Notice that it's intersecting here along a line. Okay, so when two planes intersect, they always intersect at a line. And again, remember that these planes go infinitely in both directions. I'll show you another picture here of kind of what we mean here. I just did one plane here I've illustrated, and it's a red one. Now, while this red one looks like a box or a square, realize that it keeps going on every direction. Okay, so it's like an infinite sheet of paper. Here's a flat sheet. You can see it has like no thickness here. Of course, it looks like it has a little bit, but we would know that it has none. Now, what I've illustrated here, just to hit this one home here, is underneath here you can see I made one point here, this little point. And this little point here is not in this red plane. It's actually not what we would call coplanar. It's not coplanar. Now I made three other points here, and these are actually coplanar points. You can see if I kind of move this to the side here, these 2 points here are actually in the plane. Okay, these ones are, and I can just illustrate that right here. You can see they're in the plane right here, as well as down here. Okay, so they're in the plane, whereas this one obviously is not. It's below the plane here. This one's actually also in the plane. I made it in the plane with the coordinates that they are, but I just want to show you that, it may not look like it's in the plane, but in fact, these are all in the same plane. It's just this red plane we quit drawing, but of course we know that it keeps going, and if we actually did continue it, it would of course run into this dot. And so all three of these points right here, 1, 2, and 3, are all what are called coplanar because they're all in that same plane, whereas this one is not. Now, in fact, I could take any one of these 3 points here, even this one that's not coplanar, and these two, and make only one plane between them. In fact, if I kind of line them up like this, you'll see that I could take a plane and shove a sheet of paper going through all 3 of these points. Similarly, I could take a sheet of paper going through these 2 points. through any 3 points, whether collinear or not collinear, or pardon me, any 3 non-collinear points, has to be non-collinear, there's only one plane. And I just wanted to kind of illustrate here. Hopefully that hits it home. It's a little harder to demonstrate this on a board, much easier in 3 dimensions.